Imagine standing in front of a sample that contains hundreds of molecules, many of them differing by only a fraction of a mass unit. Traditional analytical tools struggle here. This is where high-resolution mass spectrometry, or HRMS, becomes indispensable. Today, we'll explore how HRMS works at a fundamental level, and more importantly, why it has become the gold standard for analytical excellence in pharmaceuticals, environmental science, and biomolecular research. High-resolution mass spectrometry is designed to measure molecular masses with extraordinary precision. Unlike low-resolution mass spectrometry, HRMS can separate ions that appear identical on conventional instruments. This capability is critical when you're dealing with isobaric compounds, trace impurities, complex biological or environmental matrices. In real analytical labs, HRMS doesn't just detect compounds. It confirms their identity with confidence, which is essential for regulatory and research-driven decisions. Every HRMS experiment follows a structured three-step process. First, molecules are converted into ions. Second, those ions are separated based on mass-to-charge ratio. Third, the ions are detected and transformed into meaningful data. Each step must be optimized carefully, because errors at one stage cannot be corrected later. This integrated workflow is what allows HRMS to deliver both qualitative and quantitative insights. Ionization is where the HRMS journey begins. The goal is to convert neutral molecules into charged ions while preserving their chemical structure. This is especially important for sensitive compounds such as peptides, proteins, and drug metabolites. Choosing the right ionization technique is not a technical formality. It directly determines sensitivity, accuracy, and reproducibility. Once ions are formed, they enter the mass analyzer, the core of the HRMS system. Here, ions are separated based on their mass-to-charge ratio, or M/Z, with extreme accuracy. This is where HRMS truly earns its name. Different analyzers offer different strengths, and selecting the right one depends on the application. After mass separation, ions are detected and converted into a mass spectrum. But the real value lies in data processing. Advanced software analyzes isotopic patterns, predicts molecular formulas, and integrates statistical models. This step transforms raw spectral data into actionable scientific insight, supporting both innovation and regulatory compliance. HRMS offers advantages that conventional MS cannot match. These include high-resolution, accurate mass measurement, structural elucidation, exceptional sensitivity, high reproducibility. Together, these strengths make HRMS indispensable in high-stakes analytical environments. HRMS supports a wide range of applications. In pharmaceuticals, impurity profiling, bioanalysis, nitrosamine detection. In environmental science, PFAS and extractables testing. In food safety, residue and contaminant screening. In advanced research, peptide sequencing, lipidomics, and biomarker discovery. At Resolve Mass Laboratories, HRMS workflows are designed with regulatory expectations and scientific rigor in mind. Customized methods, reproducible results, and deep analytical expertise ensure data you can trust across pharmaceutical, environmental, and food safety industries.